Unit 8, Lesson 4, Part 2. The law of signs involving the ambiguous case. This is when the given information gives you one side of a triangle, the next side, and then the angle that follows the second side. Anytime you have an opposite pair, but the given information is in the SSA format, it means there can be one solution, two solutions, or zero solutions. Now, forgive me if I offend any of you. However, the ambiguous case is a pain in the ASS, which is side-side angle, spelled backwards. It does require extra work, and you do need to check for extra solutions. It's best to look at this through a graphical example. If you were asked to draw a triangle with A equal to 10, angle B is 36.9, and side B is 6.5, there are actually two triangles that we can draw. If I call your attention down to these two triangles at the bottom, you'll see that the 36.9 and side 10 look exactly alike. They're in the same place. However, the 6.5 in this case forms an acute triangle. However, the same 6.5 side can be reoriented to draw an obtuse triangle where A prime is the obtuse angle. What does this mean when we deal with our first example? In example 4, triangle ABC, we're given the following information. If we use the same diagram structure, you'll see that we have the opposite pair of side B and angle B, and then we have side A. So it makes sense to use the law of signs to solve for angle A. We can set up our equation, cross multiply, use sine inverse. We come up with angle A is 61.8. Just like in the previous examples, we can use the 180 rule to solve for the third angle, which is 82.2. Our last step would be then to set up the law of signs again, cross multiply, solve for side C, which we get as 13.5. This is the place where students often will make mistakes, and you need to be aware of this. If you look back, 8 is followed by 12, there's your side, followed by the angle 36. This is the ambiguous case. It means we may be able to draw a triangle like the one on the right of the screen. Rather than 8 forming an acute triangle side, it actually creates an obtuse triangle. The question is, what's A prime? Remember, A prime is located in the general same area as A. Well, it turns out that if you know angle A, use its supplement, 180 minus 61.8, to come up with A prime. Once we have A prime, we then can use the opposite pair of side 8 with angle 36, and we can solve for C prime, which is the length of C. Turns out to be 5.9. In example 5, similarly, we can set up our triangles. 120 is paired with 17. We have side B is 12. We're asked to solve the triangle. We're going to find angle B in this case. Using the law of signs, cross multiply, use sine inverse, we get angle B is 37.7 degrees. Using the 180 rule, we can find our third angle. Setting up again using the law of signs, we can cross multiply and solve for side C, which is 7.4. However, when we move to the second triangle, obviously this is not drawn to scale because we have 120 degrees that was given to us. That is not an acute angle. Taking angle B, using its supplement, we get 142.3. If we subtract from 180 using the 180 rule to find the third angle, we're going to determine that there's no degree measurement that can be found to represent that third angle, so there's no solution. In this case, there would only be one triangle that represents the solution to the answers. In our last example, there were two triangles. This is what you must verify anytime you're using law of sines with SSA. Lastly, example 6. Setting up our similar drawing, seeing that we have an opposite pair, setting up the law of sines to find angle C. When we put this in the calculator, it's going to give us an error. And it has to do with the fact that the lengths of 6 and 7 are not appropriate across from a 65-degree angle. Because we get an error on the first calculation, there are no triangles that we can draw. So there are no solutions to example 6.